Hi guys, in this video we'll use static and dynamic analysis to understand the encryption algorithms. Open IDA Pro. Let's load the sample in IDA and start the static analysis. Also, let's load the Solarized theme. If you remember from the process monitor window, the function that writes the encrypted buffer is at location 0x401-203. We'll again rename the two functions for clarity, encryption 1 and encryption 2. Maybe you remember that encryption 1 was never called because the value of this constant is always positive. Nevertheless, let's still analyze it quickly. For encryption 1 in EAX, we have the length of the buffer, which is compared against a maximum value. If it's less than that, the buffer is then split into 16 bytes chunks, and for each chunk, some operation is applied, which is actually an XOR operation with a static key. Very simple. This is the repeated 16 bytes key. We know this already. Let's look at the second one, which seems more interesting. In encryption 2, LP buffer contains the text of the file and EAX contains its length. The buffer is split into 8-byte blocks using a shift right by 3 positions. For each block, the following operation is applied. Let's call it encrypt block. This function looks a bit more complicated, but notice we have a lot of constants. For example, this one over here and the next one. If we do a quick online search, we'll find that they belong to a well-known encryption algorithm called XT, for which there are Python implementation and C source code already available. We also have other constants, unknown for now, which are created dynamically on the data section. Notice their value is a question mark. If you want to know where they are created, we can check the cross references. Use the X key. If we look at the type of the operations, the values are only written in one function. If we cross-reference that, we can see that it's called only in the start routine, close to the beginning of the execution. To get the values of these constants, we'll set a breakpoint after the call to this function. Press F2 for that. And then, let's now see how to do dynamic analysis in IDA Pro. Use local Windows debugger and restart the sample. Read and accept the warning. Remember that the sample enters an infinite loop because it has an anti-virtualization protection. Pause the program. The execution stops in NTDLL, which is a Windows library. But there are 2 threads, and the second one is right inside our code. Remember, we have to patch the test instruction. Increase the value of the EAX register by 8 to get 39. F8 again, and notice that now the execution continues. If we let it run, we reach our second breakpoint. This is the function that initializes our constants. Execute the function by pressing F8, then go back to the encryption routine. And there we now have the values of those constants. It's very useful to know how to perform dynamic analysis in IDA Pro. So, We also learn how to identify known encryption algorithms from assembly code. Thank you and see you in the next video.